8 to 9 or 8:30 to 9:30?
8:30 to 9:30, sir.
8:30 to again, same time.
Same.
Okay. Still, our friends are joining or we'll start? Okay, here I am going to give you more clarity of this yesterday's class. Okay, basically what we are going to have is principle of the engine emissions. On SI engines is CO, HC and NOx. And spark ignition engines are petrol engines. SI engines pollutants will be CO, HC and NOx. And compression ignition engines means diesel engines where you have the CO, HC, NOx and PM. CO is the carbon monoxide, HC is the unburned hydrocarbon, and NOx is the nitrogen oxides, mainly mixture of NO and NO2, and PM is the particulate matter. Other engine emissions including aldehydes and such as formaldehydes and acetylene aldehyde and primarily from the alcohol fuel engines and benzene and propane hydrocarbons we will be having. The source yesterday I told about the engine pollution is one is the engine exhaust and other one is called the evaporative losses they coming from the engine and the evaporative loss coming from the fuel tank. The figure 1 shows here emissions sources in the gasoline fueled car, spark ignition engine car. If you take it, evaporative losses will be coming through this engine where you have the air will be entering into the carburetor. There we are going to have the carburetor and air fuel mixture will be taken, and that will be having the some small evaporative losses will be there. And each and every fuel tank in my two-wheelers maybe see small hole on the cap of the nozzle, and according to the environment temperature conditions, and petrol is a highly vaporable and it automatically evaporates the evaporative hydrocarbons from the fuel tank. We're going to see, and you can see the exhaust also, where you are seeing the exhaust, where you have the HCC and CO and NOx. You should remember that SI engine will have CO, HC and NOx will be coming out from the exhaust, and we have evaporative losses also will be having the hydrocarbons will be coming out and going to the atmosphere through the fuel tank and the carburetor. This is the major emissions from the spark ignition engines of a SI engine. SI engine means petrol engine cars. And we are going to see this, if you have a diesel bus or diesel car transporting vehicle, what are the emissions will be coming up? One is the carbon monoxide, CO, this also will coming, HC, NOx and smoke. But in particularly in diesel engines, diesel will be more concentrated, it will not evaporate it very easily. And if temperature is very high, it may evaporate. But evaporative losses from the tank and here we are not having carburetor. We have a fuel injector will be there. Air and fuel will be bond inside the combustion chamber. From that only we are going to get the power. That's why what happens here, the evaporative losses is very less in diesel engines. Where the temperature is very high and atmospheric condition is different, then only we'll get the loss. But most of the losses will be coming out from the exhaust only. Because CO is the carbon monoxide and HT is the hydrocarbons, NOx will be coming. And little bit so SOx also will be there, but SOx is a very minute percentage. And smoke also will be there. That is a particulate matter. It is a very dangerous, where you have the exhaust gases coming out from the diesel engine, and the smoke will have a lot of PM particulate matter that will be will be having a lot of damage to the environment. And actually, emissions of the pollutants, engine emissions undergoes a chemical reactions. I told that's only our friend's question. Photovoltaic, photochemical process he is asking. Engine emissions undergo chemical reactions in atmosphere known as largely as a photochemical reactions and give rise to the other chemical species which are hazardous to health and environment. Linkage of engine emissions of air pollutants is shown in figure, and this figure will shows how the engine emissions are coming, how the photochemical reactions will be happening, And simply way, I'm going to take this thing for his question. I'm not going in deep because it's a chemical engineers, chemical, we may not be knowing. But according to our fuel, according to our combustion, according to our exhaust, what are the things will be coming? And engine emission will be coming as engine emission directly has CO becomes CO only. But where you have an HC hydrocarbons, the hydrocarbons will be formed as oxidants, and hydrocarbons will be having a TS and SPN. I will tell you total suspended particulate matter in air, and PA is the acetylene nitrite, where we are going to have acetylene acetyl nitrate. This will be there. And through hydrocarbons and NOx and particulate matter only will use a lot of hazardous things will be coming out from this, and a lot of reactions will be coming. This thing HC, NOx, PM only will be coming more reactions. CO of the engine will comes as a CO only, and we are inhaling the CO as it is, but HC will be having reacting with outside the environment and outside the temperature and air and air pollutants. And this, if you go in detail, and photochemical smog is a brownish gray H resulting from the reactions caused by a solar ultraviolet radiation between the hydrocarbons and oxides of nitrogen atmosphere. The ultraviolet rays of sun rays, because I told the temperature. When the temperature is there, temperature also having a reaction with this HC hydrocarbons, NOx, and particulate matter will reactions with oxidants, and we are going to form this the air pollutants such as ozone nitrate and organic compounds of proxy acetylene nitrate, this is called PAN, and CH3CO and NO2 are the chemical equation. We have trapped near the ground by temperature. Invest temperature inversion experienced especially during winter months. These chemical substances can affect the human health and cause damage of the plants. The photochemical reactions are initiated by nitrogen oxides emitted by vehicles into atmosphere. A simple set of reaction leads to photochemical smog formation is as follows. NO2, NO2 plus HCV and ultraviolet rays will give the NO nitrous oxide and O will be giving. This O plus O2 gives O2, and NO plus O2 gives NO2, O2, and HV is the energy of a photon, and UV is ultraviolet light radiations. This will be mixing here, and we are going to get the equation of this one. And HC and NO do not necessarily involve ozone and provide another route to form NO2. And thus the concern, the above reactions from the NO to photovoltaic cycle. However, if only these reactions are involved, then NO2 concentration in the atmosphere would remain constant, but volatile organic compounds VO, CS, and include the under unburnt hydrocarbons and their volatile derivatives also react with the NO and O2 to form into NO. This is the actually photochemical reaction, and with the ultraviolet rays and with the outside air will use the reactions and it depleting the ozone layer. The reaction between the of the ozone and NO2 in the urban air rises. The most reactive VOC is atmospheric and olefins, that is called hydrocarbons with CC bond. A general reaction between the hydrocarbons and NO may be written as RHNO plus O2, and this is called UV rays. And NO2 we are going to be a pan. And main process of this photochemical smog formation as shown in figure VOCS and NO will use that is called volatile organic compound. VOC means plus NO will react with O2 and O3 ozone layer and HNO3 and organics will be having. This is about the from vehicle what the exhaust and evaporating gases will use the particularly what the formations will be there. You can see in the picture. And the harmful constituents of the photochemical smoke are NO2, O3, PAN, and aldehydes. The PAN and aldehydes cause eye irritation. NO2 and ozone are strong oxidants and cause damage to your nose and bronchitis and chest. It goes inside and materials of the plants. And it damages the persons, it materials the ozone layer, causes the plant to growing also. If you go in detail about photochemical reactivity and hydrocarbons, the exhaust gas of gasoline engines contain more than 150 different hydrocarbons and their derivatives. Some hydrocarbons are more reactive than the other. The photochemical reactivity of hydrocarbons has been measured in terms of the rate at which the specific hydrocarbon causes the oxidation of NO and NO2. The determination that determine the rate of photo oxidation and NOx presence. We also can see it in the tabular form and it is given. And particularly in photochemical reactions, will causes a lot for the environment. That is the main content where we are discussing. And where we have the health and effects of the pollutants. Because I already told that a lot of effects will be having by inhaling of the, particularly in diesel or petrol exhaust, and we are going to get this will be very heavy this thing. And I have given the tabular form there, advise the health effects of the IC engines generated by the air pollutants. One is the carbon monoxide, headache, and shortness of breath. That is called once if you polluted thing will be going inside our nose, and if you need sufficient oxygen percentage is not there, you will get a lot of unconsciousness and shortness of breath and dizziness and impaired judgment and the lack of motor coordination and all. And long-term health is effect on brain and central nerve system. Uh, and we have nose and vomiting session and cardiac problems and pulmonary problems. And you have change of loss of the because it will affect the unconscious nerve system, then it may loses your consciousness and death also. Nitrogen also will have the uh, uh, soreness and we have coughness, chest distortion, eye irritation, and development of stenosis, especially in at limbs, fingers, and toes. Adverse and, changes uh, in cell structure of the lung walls. And we have oxidants and we have the ozones and similar to these officially breathing chest tightness, eye vision will be lost by oxides of nitrogen and impaired lung diseases and increased suspense. A lot of things, respiratory problems will be coming out from your health resorts. And ozone also, ozone layer and development of emptiness and pulmonary diseases. And we have the other things. And TSP recipient responsible for the suspension of increasing success of the various pollutants. And a lot of hazards will be coming out from your health issues. And this is another table where you have problems from the history of from 1952 to 2004 and how the pollution levels will be increasing, how the damages are coming to the persons from things and all. Emission control A, and we have a historical mode because we have taken a lot of steps for reducing of the emissions, like having the catalytic converters, having the Euro 4 norms. Euro 4 norms will be better than the Euro 1, Euro 2, and Euro 3 norms. And a lot of changes has come up on engine designs and engine modifications, and a lot of electronics is involved to control the rich mixtures ending inside the engine and all. These all will help you to improvising of the engine design and all. It gives the less pollutants from the engines. And these are all about the doubts and clarification of our friend. And now we'll go to our lecture or we'll close. Okay, now we'll discuss about hydrocarbon emissions from the CA engines. And this is called injection nozzle, where we are going to inject inside the engine. And overmixing of the fuel and air during the ignition delay period. The evaporated fuel mixes with the air regions of the fuel air mixture are produced that are too lean to burn. Basically, what happens in diesel engines, air and fuel will mixing inside the combustion chamber. Here you are seeing the picture where you are how fuel injector will be seeing it here. From the fuel injector, the fuel will be spreading over here like a balloon, and it will be having the where we have the rich mixture will be saying greater than 1 in here, and Q is less here, and QL is here, and Q is having injection nozzle, and fuel jet boundary will be there. And the injection location also will be seen it. Here it will be having the injection. And overmixed HC also you can see it here, the layer where you have two layers, you will be seeing it here in the dotted lines, will be overmixing of the hydrocarbons. And overmixing of the fuel and air during the ignition delay period, evaporated fuel mixes with the air regions of the fuel air mixture are produced that are too lean to burn. Some of this fuel makes its way out the exhaust, and longer ignition delay, more fuel becomes overmixed. Undermixing of the fuel and air, a fuel leaving the injector nozzles at low velocity at the end of the injection process cannot completely mix with the air and burn, because overmixing and undermixing also will be having a lot of problems in the combustion of these CA engines. In the volatile organic compounds, where we have a general term for a wide range of hydrocarbon compounds, basically whatever these pollutants will coming out from the exhaust only, but particularly in diesel engines, VOC results the combustion process and the evaporation of gasoline vapors, solvents, etc. Because where we have the hydrocarbons evolvement will be there. Particularly in diesel engines, we have exhaust, and the petrol engines, two-way it will come from the exhaust and the evaporating losses also. Both way you can going to get the hydrocarbons. They contribute to on a global warming. In sunlight, they combine with NOx to form the ozone, smog and all. Ozone irritates eyes, aggravates respiratory problems, illness, and damages crops. And the ozone problem is the one affecting the most people's paddy, and it will be effects to the plants also. Now, simply you are seeing that in the news after Punjab particularly, and Delhi, why it's having more polluted? Because one side is having the vehicles pollution, another side the burning of the crops in Punjab, and that smoke also coming to the Delhi, and it will be aggravating the exhaust pollution. Normally, in some before summer, it will be becoming a lot of problems. So this crop burning, and through crop burning also, where you have one burning, and automatically combustion exhaust gases will be coming, and that exhaust gases will leads you to get the problems of these things, because where you have combustion, there you have pollutants will be coming out. And oxides of nitrogen, NOx. Nitrogen oxide is the prominent one. It's a prominent one, that yellow brown color is smog. NOx results the high temperature combustion process. Example, cars and utilities. They affect the respiratory system. They play a major role in atmosphere. Overall levels of unchanged, but transportation source are cleaner. And a NOx formation, I already explained it. And here also you can see the reactions. N2 plus O gives NO plus N. N plus O2 gives NO plus O. N plus OH gives NO and H. These also reactions will use you for photochemical reactions of the NOx. And the lead, I told already lead content will be there in the petrol. Previously it is very high. Now they reduced the lead content. And long known as one of the worst toxic in the common use of the lead, emitted from the gasoline additives, battery factories, and non-ferrous smelters. Where you have the gasoline automobile petrol engines, where you are going to get this lead content from the exhaust. And the battery factories also getting, because lead acid batteries will be manufacturing many of the industries, and batteries also manufacturing units also give the lead content to the atmosphere, leaving to the atmosphere the air to exist. And non-ferrous smelters also reduce the lot of things to the effect of various organs, and can cause sterility and neurological impairment. Example, retardation and behavioral disorders will be coming through this lead. Infants and children especially suspectable, and the control of mobile sources has been exceptionally successful. And these are all things, lead content will be very dangerous to have the content to causes the damage to the persons who are inhaling to the exhaust of the SI engines. And we have in this, particularly in diesel engines, particulate matter also PM10. PM10 is a general term for tiny airborne particles under 10 microns, very minute microns, exhaust, dust, soot, and smoke. And exhaust will gives releases to the dust, smoke, soot like a smoke, exhaust gases. Primary sources are fuel bonding plants and other industrial commercial processes, and some are found in the air. They irritate the respiratory system and may also carry metals, sulfides, nitrates, and oxidants. Our friend is asking of what ppm will contain. Ppm will contain a lot of metallic particles, and we have the sulfates and nitrates will be coming out from this exhaust gas. Some overall decreases seen, but the trend may be masked and meteorological changes. And the particulates, a high concentration of particulate matter is manifested as a visible smoke in the exhaust gases. A high concentration of particulate matter, PM, is manifested as a visible smoke in the exhaust gases. And whatever you are seeing it in the figure, and whatever you are behind the diesel transportation vehicle, whatever the exhaust will be coming out, that exhaust may be having a lot of things in this. Particulates are any substances other than the water that can be collected by filtering the exhaust, classified as solid carbon material or soot. And we have some precautions measures we are taking it for collecting of these particles, particularly what we have the previous discussed particles will be solid carbon materials or soot, condensed the hydrocarbons and their partial oxidation products. Diesel particulate consists of a solid carbon soot at a exhaust gas, temperature below 500 degrees centigrade. Hydrocarbon compounds becomes observed in the surface. In a properly adjusted SI engine, soot is not usually a problem. Particulate can arise if leaded fuel is overly rich fuel mixture used. Burning crankcase oil will also produce the smoke, especially during engine warm up, where the hydrocarbons condense in the exhaust gases. These are all particulate matter in diesel engines or petrol engines. What we are going to get through this particulate matter, and how it will cause us to it. And mechanism of formation of particulate soot will be having. The soot formation process is a very fast, because once the combustion starts, automatically exhaust gases will be coming out. 10 to 22 degrees, 10 to 22 carbon atoms are converted into 10 to the power of 6 C atoms, carbon atoms, in less than 1 minute per meters per second. 1 minute per second, because whatever the exhaust is coming out, that will be mixes of carbon atoms, will mixes very easily with the air, and you are going to get based on equilibrium composition of the fuel oxidizer mixture soup, formation occurs when x greater than or equal to 2a or x by 2a greater than or equal to 1. In the following reaction, CXHO is U plus A O2. Exponent is O and 2ACO plus Y by 2 H2 and X minus 2A of carbons per second. Experimentally, it is found that the criteria CO ratio of onset of soot formation is between 0.5 and 0.8. The CO and H2 CS are subsequently organized in the diffusion plane to CO2 and H2O via the following second stage. CO plus half O2 gives CO2, CS gives plus O2 gives CO2, H2 plus half O2 gives HO2. Any carbon not oxidized in the cylinder ends up as a soot in the exhaust. Sulfur dioxide, SOx, and the term is used for a number of compounds containing sulfur. This term is used for a number of components containing sulfur, formerly caused by a burning of a coal, oil, and various industrial processes. This can affect the respiratory system. They react in the atmosphere to form acids, sulfates, and sulfides. Substantially reduction due to control to the source through use of low sulfur fuels. Low sulfur fuels also can be using for getting up the low pollutants. And other air pollutants, carbon dioxide and uh, chlorofluorocarbons, and we have formaldehyde and benzene. And carbon dioxide will forms as like a particles which are asbestos particles, and chlorofluorofluids will be having manganese particles, and formaldehyde dioxins, and we have benzene will be cadmium will be having. Still other which are not yet to be fully characterized. And we have a global warming will be there coming. Certain gases in the atmosphere to uh, troposphere absorbs some of the infrared radiation reflects from the earth. Carbon dioxide is the major one. It will be having the role of 50% of the role will be playing. The carbon dioxide will be having the problem. Other includes methane 18% and CFCs chlorofluorocarbons will have 14%, and chlorofluorocarbons also responsible for destroying the stratospheric ozone layer. The United States produces over 20% of the world's greenhouse gases. The combustion process theoretically, C7H13, the gasoline chemical formula, and 10 plus air we are mixing it, 10% of the O2 will be giving, 10 O2 and plus 39 N2 will be given, and we are going to form as a 7 CO2 and 6.5 H2O, and we have 39% of N2 will be coming up. Carbon dioxide will be coming 7% of CO2 from the gasoline engines, and 6.5 H2O will be coming from the steam formation, and we have the 39% of nitrogen, and we have the combustion process actually. Today's air and the real fuel, and we have pollutants, unbound hydrocarbons, carbon monoxide, oxides of nitrogen, other elements of compounds, and the exhaust will be having nitrogen, water, steam, carbon dioxide, and pollutants. And other emissions will be having, I talked about the evaporative losses. You can see it, refilling losses, displaced vapors will be there. And crankcase losses also were due to blow-by. And miscellaneous emissions due to other operation and wear of brakes, brake tires also will give some losses of it. Other emissions in motor vehicles. The motor vehicle is a source of air pollution, refilling losses, evaporative emissions, crankcase losses, exhaust emissions losses. Now you can see this is how the emissions are formed. And in the engine, the incomplete combustion, valve pinch, high pressure and temperature blow-by due to evaporation of fuel, breathing, and hot engine and fuel displacement of vapors. These are how the emissions are formed in the internal combustion engine. And then we go to the emission control. Tomorrow we'll discuss about the emission control and all. Okay, okay, friends.
Yes, sir. No problem.
Any doubts, any clarifications? Today's class?
No, sir.
Huh?
No, sir.
No doubts. Okay. You can leave the meeting. Hmm? Okay, friends. Bye. Okay, next week onwards we'll change the times.
Yes, sir. I will call you. We'll talk it about that.
Okay, 2 to 3. Okay. Confirm it
I
by
will,
next week.
yeah, I will call you, sir, before
Okay.
confirmation.